Welcome to your comprehensive interactive study breakdown on bonding, structure, and the properties of matter. This is the most foundational topic in GCSE Chemistry. It explains why diamond can cut through rock while graphite in your pencil easily flakes off, even though both are made entirely of carbon atoms. Understanding bonding is critical because examiners constantly ask you to explain physical properties like melting points and electrical conductivity. To secure those marks, you must identify the type of bonding, ionic, covalent, or metallic, and the resulting structure. Let's dive in. Let's map out the three main types of chemical bonds. Ionic bonding occurs between metals and nonmetals, where electrons are transferred to form oppositely charged ions held in a giant lattice. Covalent bonding happens between nonmetals, where atoms share pairs of electrons, forming either simple molecules or giant covalent structures. Metallic bonding involves a lattice of positive metal ions surrounded by a sea of delocalized electrons, which explains conductivity and malleability. Turning to our core study notes, ionic compounds like sodium chloride have high melting points because of the strong electrostatic attraction between oppositely charged ions in a giant lattice. In the solid state, ions are fixed and cannot conduct electricity. But when molten or dissolved, the lattice breaks and ions become mobile, allowing conduction. Remember the key phrase, electrostatic attraction between oppositely charged ions. Covalent bonding involves sharing electrons between nonmetal atoms. Simple molecular substances like methane have weak intermolecular forces, so they have low melting and boiling points. In contrast, giant covalent structures like diamond and graphite have strong covalent bonds throughout the entire structure, giving them extremely high melting points. Diamond is hard because each carbon atom is bonded to four others in a tetrahedral lattice. Graphite has layers held by weak forces, allowing layers to slide off. Let's work through a 6-mark exam question. To secure full marks, first identify the bonding as ionic. Then describe the giant lattice structure. Explain that the strong electrostatic forces require a lot of energy to overcome, leading to a high melting point. For conductivity, state that in the solid state ions are fixed, but when molten they become mobile and can carry charge. Always use the key phrase electrostatic attraction between oppositely charged ions. Watch out for common pitfalls. Many students confuse ionic and covalent bonding. Remember that ionic occurs between a metal and a nonmetal. Always use the phrase electrostatic attraction when explaining ionic compounds. Don't forget to distinguish between simple molecules, weak intermolecular forces, and giant covalent structures, strong covalent bonds. For metals, say delocalized electrons, not just free electrons. These small details earn you marks. To wrap up, match the bonding type to the elements involved. Ionic bonding gives high melting points and conductivity when molten. Covalent bonding can give low melting points for simple molecules or very high for giant covalent structures. Metallic bonding explains conductivity and malleability. Also remember nanoparticles have a high surface area to volume ratio, making them useful as catalysts. Master these concepts and you'll unlock high marks across your exams.